You might have used some of Excel's built-in functions for calculating probabilities or percentiles for theoretical distributions. For example, the normDist function finds left-hand tail probabilities for a normal distribution, and the norminv function looks up percentiles for a normal distribution. Here are a couple of examples. @RISK provides similar RISK-Theo functions, where Theo is short for theoretical. These functions are described in this video. Recall that when you open a distribution from @RISK's Define Distributions window, you see a graph such as the one you see here. It includes a variety of summary measures in the right pane. These summary measures are the values calculated by the RISK-Theo functions. You can find a list of all RISK-Theo functions in the theoretical group under the Insert Function dropdown on the @RISK ribbon. For backward compatibility with previous versions of @RISK, several of these are equivalent. Specifically, RISK-Theo P to X and RISK-Theo Q to X are equivalent to RISK-Theo percentile. Each finds the percentile of the distribution for a specified percentage. Also, RISK-Theo percentile D, D for descending, is essentially equivalent. If its percentage argument is, say, 0.05, it returns the 95th percentile. Similarly, RISK-Theo X to P and RISK-Theo X to Q are equivalent to RISK-Theo target. Each finds the probability to the left of a given value. RISK-Theo target D finds the probability to the right of a given value. The worksheet you see here illustrates several examples of RISK-Theo functions. Each of the cells in green font in row 2 contains an @RISK distribution function with the parameters shown below it. Then various RISK-Theo functions are used in rows 9 to 16 to calculate various summary measures of these distributions. RISK-Theo mean, standard deviation, minimum, maximum, 5th percentile, 95th percentile, which I've done with the D version using the 0.05 argument, the probability of being at least 2 standard deviations below the mean, Theo target, and the probability of being at least 2 standard deviations above the mean. Here I've used the D version for the right-hand tail. Several of these return value errors. This is because the minimum or maximum of some of these distributions is unbounded. There are 2 things to note about RISK-Theo functions. First, they are not based on simulations. Simulation, after all, is all about estimating distributions of outputs that are functions of input distributions, often very complicated functions. In contrast, RISK-Theo functions operate only on the gallery of @RISK input distributions. In fact, RISK-Theo functions are essentially hardwired to these input distributions, so they return exact values, not estimates from a simulation. Second, the only arguments RISK-Theo functions accept are @RISK distribution functions. Again, this is because of the way they are hardwired to these distributions. To convince yourself of this, enter the formula equal 2 times B2 in cell B3. Now try taking RISK-Theo mean of this. It doesn't work. You get an error. Actually, if this did work, you would have a gold mine. You would be able to find means of functions of input distributions without any simulation. so you wouldn't need simulation at all. Again, RISK-Theo functions have essentially the same value as Excel statistical functions like normDist and norm-INV. They allow you to calculate summary measures of many commonly used theoretical distributions. The advantage of RISK-Theo functions over Excel functions are that they have more functionality and they apply to more distributions. For example, Excel 2010 has a Weibull.dist function for calculating probabilities of a Weibull distribution, but it doesn't have a function for calculating the mean, standard deviation, or percentiles of a Weibull distribution. Also, it doesn't have any functions at all for many of the lesser-known distributions in at-risk gallery, such as logistic, Pareto, PERT, and others. The risk SimTable function is often used to test several values of a decision variable so that a best value can be found. The at-risk RISKOptimizer tool can be used to take this a step further. It allows you to maximize or minimize a selected summary measure of any at-risk output cell by varying selected adjustable cells, where adjustable cells refer to values that can be varied to optimize the summary measure. For example, you can maximize mean profit, minimize the standard deviation of profit, maximize the 5th percentile of profit, or even maximize the probability of making profit greater than $500,000. This video introduces you to RISKOptimizer. It is a very powerful tool, and an entire chapter of a book, or even an entire book, could be devoted to it. To learn more, you can view the other RISKOptimizer videos in the guided tour series, and you can examine the many RISKOptimizer example files that accompany at-risk. First, if you are used to earlier versions of at-risk, you should realize that RISKOptimizer is now totally integrated into at-risk 6.0. You don't need to load it separately. It is in the Tools group of the at-risk ribbon. Note that the RISKOptimizer button is actually a drop-down. It provides the list of options you see here. To use RISKOptimizer, you must first set up an optimization model. This has been done for the airline revenue management model you see here, which is one of the at-risk example files. An airline sells discount and full fare tickets on a particular flight. The model assumes that all passengers will purchase discount tickets if they are available, but if they aren't, some passengers will be willing to divert to full fare tickets. The airline must choose limits on the number of discount and full fare tickets it will sell. It doesn't want to sell too many discount tickets because this will limit revenue from passengers who would be willing to divert to full fare tickets. Also, it doesn't want to sell too many full fare tickets because of potential overbooking. The model has been set up correctly, as you see here. There are uncertain quantities in the cells with green font. The total demand for tickets, the number willing to divert to full fare tickets, and the number of ticket holders who show up for the flight. The decision variables are in the cells with blue font. Any values can be entered initially. The single at-risk output cell is the profit cell. The goal is to use RISKOptimizer to find the values of the decision variables that maximize mean profit. To do this, you click the RISKOptimizer drop-down on the at-risk ribbon and select Model Definition. Then you fill out the dialog box as shown here. You must specify, first, whether to minimize or maximize. Second, an output cell, the profit cell. Third, a summary measure of that output to optimize. Mean has been chosen here, but as you can see, there are many other choices. Fourth, the adjustable cells and bounds on them. And fifth, any constraints. In this model, the goal is to maximize mean profit. The adjustable cells are the ticket limits in cells C19 and C20, and suitably wide bounds have been specified for them. Also, they are required to have integer values. Finally, there is a single constraint, used here mainly for illustration, that the 5th percentile of profit must be at least $10,000. In terms of adjustable cells, you actually have 3 choices under the values dropdowns: any, integer, or discrete. The any option allows a continuum of decimal values. The discrete option, with a step size of 5, say, would allow only the values 0, 5, 10, 15, and so on. This option can be used to speed up the optimization. To illustrate the mechanics, I will delete and then add an adjustable cell and the constraint. So I will delete this one, and I will add a new adjustable cell, C20. I'll put bounds, and I will require this to be integer. For the constraint, I will delete it and add it back. I'll describe it as percentile for profit. It's based on profit. The measure is the percentile, 5th percentile, and I want this to be at least $10,000. There is the constraint. When you click OK on the model definition dialog box, nothing happens, at least not yet. This model definition dialog box just stores the settings. To actually perform the optimization, you will select Start from the RISKOptimizer dropdown. First, however, you can select Settings from the RISKOptimizer dropdown. This opens the dialog box you see here. You can experiment with these settings, especially the runtime settings, but the default settings usually work fine. More details about the RISKOptimizer settings are discussed in a companion video in the guided tour series. Now you can select Start from the RISKOptimizer dropdown to perform the optimization. RISKOptimizer can take some time to converge to an optimal solution. This is because it systematically checks many values of the adjustable cells, and for each it runs a simulation with the number of iterations you specify. As it runs, you see the progress in the blue text box and also in the progress dialog box. In particular, its bottom 2 boxes show the original mean profit and the best mean profit so far, so you can monitor these for progress. And if you click the magnifying glass, you can see progress in a more graphical form. Okay, it just quit. When the optimization stops, you see this dialog box with self-explanatory options. You would usually just click OK. For this airline model, the optimal solution is to limit the number of discount tickets to 109 and the number of full fare tickets to 53. The corresponding mean profit is $20,160. However, you shouldn't take these values too literally. First, they depend on the particular random numbers generated during the optimization. Another run might produce slightly different results, just as in any at-risk simulation. Second, the objective in many RISKOptimizer models, including this one, is fairly flat in the neighborhood of the optimal solution. Therefore, other solutions could have similar values of mean profit. If for any reason you would like to restore the original values of the adjustable cells, you can select Reset from the RISKOptimizer dropdown. If you look again at the model definition dialog box, you see that it shows Recipe above the adjustable cells. This is one of several solving methods available in RISKOptimizer, and it is by far the most common. The recipe method treats each variable as an ingredient in a recipe, and it tries to find the best mix by changing each variable's value independently. However, there are other solving methods, each designed for a particular type of optimization model, and examples of them drawn from the at-risk example files, are discussed in a companion video in the guided tour series. This video illustrates some options for defining your RISKOptimizer model in the Model Definition dialog box. If you haven't already done so, you should view the RISKOptimizer introduction video in this guided tour series first. The airline revenue management model that was used in the earlier video is used again here for illustration. Specifically, the objective is to maximize mean profit, and there is a constraint that the 5th percentile of profit must be at least $10,000. Note that the mean profit and the 5th percentile of profit have been calculated in cells F22 and F23 with the risk mean and risk percentile statistical functions. Their values are currently meaningless, but they will become meaningful when a simulation is run. Actually, it is not necessary to calculate these summary measures in the worksheet itself, but it is done here to show the flexibility of the RISKOptimizer model definition options. One way to specify the objective, possibly the most natural way, is shown here. The specified cell is the profit cell, F20, and the specified summary measure is its mean. If this method is used, the risk mean function is not necessary in the model worksheet. Alternatively, a completely equivalent method is the following. Here you specify the risk mean cell, F22, and the value summary statistic. Of course, this does require you to use the risk mean function in your model worksheet. So those two methods are completely equivalent. Constraints are similar. This dialog box shows one way to specify the 5th percentile constraint. You select the profit cell, F20, and you specify its summary statistic to constrain, the 5th percentile. Alternatively, you can specify the cell as the 5th percentile cell, F23, and again use the value option. Again, they're completely equivalent. The main point is that RISKOptimizer provides a lot of flexibility for specifying the objective and constraints. This just might enable you to do something you didn't think you could do. As one possible example, suppose you specify the returns from two financial portfolios as output cells, and you want to maximize the difference between their standard deviations. Then you can calculate the standard deviation of each return with the risk std-dev function, calculate the difference between these two summary statistics, and specify this difference cell with the value summary statistic as the cell to minimize. There are even more options for constraints, including hard versus soft constraints, and simple versus formula in the entry style dropdown. The soft and formula options aren't commonly used, but you can read about them in the at-risk help files.